forgot to hit record. Hi. So if we get into something extra outlandish, I have to like show you my source.
Is that a rat with one eye?
It's a cat with one eye. Yeah, my cat's name is Uno. Just kidding, I have no idea what his name is. If he was my cat, he'd have been named Uno for the 30 minutes he was alive. So here are a bunch of textbooks, and they all talk about like different lengths of DNA of stuff. And so we land on, it's about 2 meters of DNA in a cell. Then if I have 1 billion cells in the body, we think we have 100 billion, then that would be enough to, if we had 10 billion cells in the body, 10 trillion cells in the body, then we think we could go to the sun and back 667 times. If we have 100 trillion cells, then it'd be 667 times. That's a lot of DNA. So how do I keep that DNA from getting tangled up? Yeah, histone proteins. How did I get DNA to stick to histones again? Yeah, what was the charge on DNA on the sides? Was it positive or negative? Negative. The sides of DNA, I know we haven't talked about the structure of DNA really much at all, but we've seen this picture maybe once. The sides of DNA has phosphates, and anytime I think of phosphate, it comes up all the time in this class, it seems. Phosphates negatives. In Unit 2, it's phospholipid bilayers. In Unit 3, it was ATP has phosphates. So negative DNA, bless you, means that DNA can stick to histones. So if I've got a bunch of histones and a bunch of DNA and I want them to stick, there's a bunch of DNA. If I zoom in on it, it's double helix. We've determined that. We actually still can't see it. We've still never seen the double helix of DNA, by the way. So we know it's there, but we can't show it to you. We wrap it around histones, and then we take that DNA right there up at the top, and we start wrapping it around histones, so it looks like kind of like a beaded necklace or something like that, beads on a string or whatever, and we fold it, and fold those folds, and fold those folds, and fold those folds, until eventually we have what we call a chromosome. So the way that it kind of works is this. So here's what we'll do. We'll fold some DNA. And that fold is like this orange line. So it's like going like this, 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 this. Then we zoom in on the orange line. We find out that orange line is itself folded DNA. There, there, there. Then we zoom in on that purple line, and we find out it is made out of folded DNA. That fold and that fold. Then we zoom in on that, and we realize that that is made out of folded DNA. Then we zoom in on that purple line, and we realize that that is made out of that black line that is folded DNA. And that's how we fit all that crap in there. We just coil it and coil it and coil it and coil it and coil it. And we fit it all in there and manage to keep it from getting tangled at least enough for me to not die. Yeah.
Like that's the analogy you made. That's kind of like mitochondria.
Yeah.
Like times 10,000.
Yeah. I would zoom in on the cristae and I'd realize that there's cristae within that. There's like that kind of art. I don't know what it is, but they keep zooming in on it and there's like more art within the art within the art. It's kind of like that. So eventually that one piece of DNA becomes a chromosome. The average chromosome, if you unspool it and make it just double helix DNA, is about 1 inch long, 2.5 centimeters. So kind of interesting. All right, something else interesting. What are the odds that you get cancer in your lifetime? Not that I die from it, but what are the odds if there's 100 people, what percentage of them will hear from a medical professional, you have cancer? So think about it, and then we'll kind of talk about what possible answers are.
I mean, like, it's not
Now, I'm not saying some small amount that you never knew about and it never had any impact, but like I'm at a doctor's office because something's wrong, and they're like, we know what's wrong, you got cancer. Or it might be something that accidentally, maybe I don't feel bad yet, but something shows up weird on an x-ray. All right. So what do you guys think? And you can give me a little bit of a range. You're like, oh, I think it's between, give me like a 10% range or something. Yeah.
1 in 50.
Okay, 1 in 50, so a couple percent. Uh-huh. Okay, so 15%. Uh-huh. 30%. Okay, I heard a few of you guys kind of like, 30 sounded good. Uh-huh. 25. Okay, so hold that thought. Then, what are my odds that I pass away because of cancer? Now, this is out of the original 100. So just to be clear, pretend, I'm just going to pick a number that you guys said. 30%. Or wait, 30? You agreed with 30. Yeah, that's what it was. So 30. So 30 people out of 100, if 30 people out of 100 here you have cancer, then I don't mean what percentage of those 30 die from it, but what percentage out of 100 die from it. If every one of those 30 people died from it, then I would say 30. So what percentage of people die from cancer? We know that some people don't die from it, right? So whatever the number is you think that has it, the number that pass away from it has to be less. Because we know that not 100% of people die from cancer. So out of 100 people, how many do you think die from it? Yeah. 10? 20? 50? Okay. So 50 of the 15? So like 7-8% of the total 100? Okay. 5? Okay, one last question, and then I will show you answers. Or yeah, did you have 6? Okay. My last one, males versus females, who's more likely to get cancer? And then those people that are more likely to get it are also more likely to die from it. So it'd be the same answer for both. So male or female? All right. I lied. I got one more question. And then I will show you the answers to all of these. I won't just say ask you all these and then be like, all right, next up is this. What is the most common across males, females, whatever? Ignoring skin cancer. What is the most common type of cancer? The reason we're going to ignore skin cancer is very dependent on where you live. If you're near the equator, skin cancer is common. Like here in Texas, skin cancer is kind of common. If I live super north in Canada, the sun's less intense, skin cancer is much more rare. So globally, it depends very much on like where you're located. So what is the most common or the top few? Breast cancer is not number 1. It's number 2. Lung cancer? Not liver?
Brain.
Not brain? Not bone? We got a month for it right now. Prostate cancer. So prostate cancer is the number 1 most common cancer. Breast cancer is second. Females can't get prostate cancer because ain't got a prostate. But there's still more prostate cancer than anything else. So here we go. If you're male, the likelihood that you hear at some point in your lifetime that you have cancer is 43%. So 43% of males will get cancer that you're aware of at a doctor's office. Okay, now 23% of us die from it. So again, that's not 23 of the 43, that's 23 of the original 100. So that means I've got 100 people. 43 males were here, got cancer. 20 won't die from it. 23 of those original 100 will die from cancer. So I have a 23% chance of dying from cancer since I'm a male. Females, your numbers are a little bit better. You guys have a 38% chance of getting it and a 19% chance of dying from it. So females, 38 of you guys out of 100, if there were 100 in here, well, here you've got cancer. But out of those, almost 20 will make it and 19 won't. So about half of the people that hear you have cancer die from it. Just like over here, 43% got it, and about half of them die from it, as a rule. Okay, we mentioned breast cancer and prostate cancer. Breast cancer, 12% of females get it, but luckily only 3% die from it. So 12% of females will hear you have breast cancer, but 9 of those 12 will survive it. 3 of them won't.
Where is ovarian cancer on the, like?
Let's see. I'll scroll down to that in just a second. Actually, any that you guys want to look at here in a little bit, I can kind of scroll through so that you can see. Prostate cancer is worse. 15% of males get prostate cancer, but again, on the positive side, out of 15 guys that hear you have prostate cancer, 12 of them won't die from it, 3 will. So one of the reasons for that is breast cancer is external to your rib cage. So there's like a chance before I ever feel sick or something like that, that I might like just notice like, hey, there's like a bump there that didn't used to be there. If there's a bump in my pancreas, I can't tell. If there's a bump in my lungs, my ribs are in the way, so I'll never know. So I'm never going to know that I have lung cancer, most likely, until I happen to just accidentally get an x-ray for something else and they see it, or I start to have symptoms. Skin cancer. A lot of times you're just like, that looks weird. Have a doctor look at it and they're like, I agree, it's weird. We need to cut that crap out. So I've got a chance at like catching it. Prostate cancer, you can get a blood test. So every year I get an annual blood test. I am on school insurance, so it's not covered. But they check for PSA. It's a prostate antigen, and they can determine the likelihood that you have prostate cancer. So they just watch that, and if the numbers of PSA are super, super low, they're like, you probably don't have prostate cancer. It's highly unlikely you do. And then if all of a sudden it starts to bump up, then they can start like investigating. So as long as I get a PSA blood test every year, the likelihood that I catch it early is pretty good. And so that's why my odds of surviving it are pretty good. Same thing with breast cancer. Again, my odds are pretty good because I might catch and notice this weird lump before I ever have any symptoms of pain or something else. Which one is the deadliest once you have it? So for example, prostate cancer kills tons of dudes, 3% of us. But if I hear you have prostate cancer, odds are still in my favor, right? I'm likely to survive it. Which one has the lowest likelihood? Once I hear you've got this, which one is like, ooh, that's the toughest one to survive? Yeah. Not lung, huh? Pancreatic's pretty bad. It has a 5% survival rate, but we've got one that's worse than that. Yeah. Not brain cancer, huh? Stomach cancer. Stomach's kind of close, huh? No, it's not colon cancer. Not leukemia like blood cancers and bone marrow cancers. Esophagus. Now, the reason that I find that one weird, fortunately, it's uncommon. The reason that I find it so weird is I use my esophagus all the time. I'm going to use it right now. I feel like if I had something growing back there that was so bad it was going to kill me, I would have felt that when I drank some water or ate some Cheetos or something. I totally understand that I can't really feel my spleen very well. I can't really feel my lungs very well. My brain, I can't touch that. My skull's in the way. So I totally understand if my pancreas doesn't have many pain receptors. And so if there was a lump the size of my fist growing in my pancreas, I wouldn't know until I like feel pain. With pancreas, you usually don't feel pain until as soon as you have symptoms, it's usually too late. So that's why pancreatic cancer has a death rate of like 95%. Esophageal cancer, though, OMG. There's esophagus. Now, my odds of getting it are super low, 0.80, but 0.79 die. So if 80 dudes get it, 79 of them die from it. So the survival rate from that is a little bit better than 1%. Cancer of the esophagus. Again, I feel like because I'm using it, esophagus is just a fancy science word for your throat. I feel like since I'm using it every time I eat and drink, I would notice if there was something going on there. I mean, like they'll say the symptoms feel like strep throat and everything else, and you're like, yeah, but shouldn't the symptoms feel like strep throat like super, super early on? Like how's this happening when it's like, I don't know, so late? So esophageal cancer. The way that you avoid that is don't smoke and don't drink. In fact, the way that you avoid colon and rectal cancers, don't smoke or drink. And laryngeal cancer, don't smoke. Liver cancer, don't drink. So in general, if you don't smoke and you don't drink, the likelihood that you get various cancers goes down a lot. So these are males. So I'll just kind of scroll through in case there were any that you were kind of interested in. One thing that I don't understand, and I'm pretty sure that scientists don't have, they have a little bit of an explanation, but they don't have a great one. We don't really know why leukemia hits people when they're young. Pretty much every other cancer doesn't hit you until you're older. Like there aren't a whole lot of like 16-year-olds rolling around with like lung cancer or something like that. But like there are 5-year-olds that get leukemia. Like most childhood cancers are leukemia, bone marrow related, that kind of thing. Voice box is larynx, laryngeal cancer. There you go. Do you mean for young people? Or are you just asking for the stats? Okay, yeah. And then for females, Alex, were you asking about ovarian? Okay, that should be coming up. I don't know the difference between like Hodgkin's lymphoma and non-Hodgkin's lymphoma. Like I've looked it up before, but I don't recall what it is. So it's some type of lymphoma, so lymph nodes. There's ovarian. So ovarian is actually pretty low. The survival rate, though, is, yeah. Yeah. Anyway. All right. So the next thing we want to look at is this. If you're following along in your notes, most of this intro stuff, none of it's going to be on like an AP Bio test or something like that. Like they're never going to be like, how much DNA does it take to get to the sun and all that or something like that. This is just good information to know so that you can be an interesting person when you're older, when other people are just sitting around talking about politics. And they're like, did you hear that so-and-so voted this? And I don't know, the Senate whip, majority leader, bull crap, whatever. And you're like, do you know the amount of DNA in your body can stretch from the earth to the sun and back 667 times, give or take? And they'll be like, let's listen to that guy. You guys talk about your bull crap stuff that you're just regurgitating from television. Tell us more about DNA. So I'm just trying to help you guys out socially here. So this top part is all about like DNA. We wrap it around histones to pack it away. But right below that it says background genetics review. These words are kind of spread throughout your book in various places, but I kind of wanted them all in one spot. So when it says like not all in book in a central location, like they'll talk about karyotypes and genomes, but they don't really compare stuff the way that I want to. So We got a few words in there and then a few other things of interest. Okay, how many chromosomes does a typical human have? How many am I supposed to have in a cell? Yeah, 46. Now, somebody might say 23 pairs. Why would I ever say 23 pairs instead of 46? Yeah, a set from mom and a set from dad. So I get a set of 1 through 23 from mom and a set of 1 through 23 from dad. That's why we would say 23 pairs. Any other time in life, you'd never say that you're 8 times 2 years old or 9 times 2 years old or something like that, unless you're a freak. So I should have 23 pairs. Is it possible that I'm alive and I have something different than 23 pairs? Sure. What's the most common thing that you've heard of where I have an extra chromosome? Yeah, Down syndrome. So I have an extra chromosome 21. So I might not always have 23 pairs. Okay. So I have 23 pairs. How many genes are in the human genome? The genome is like the entirety. It's like the total. It's like the gene ecosystem. How many genes are in a full set of 46 human chromosomes or a set of 23 chromosomes? How many genes are there, do you think? How many genes does it take to code a human? Huh? Maybe a million? I would have thought at least a million. However, shock your dinner guests, 20,000. How many all right, so if I've got 20,000 genes, estimates are 20 to 21,000 are the most common estimates. Some go as high as like 25, some go as low as 19, but the ones you hear cited the most are like 20, 21,000. So there's 20 or 21,000 lines of code to code for a human. That seems ridiculous. We'll explain how that's possible later. What about rice? How many genes do you think rice has? Rice has about twice as many genes as you and I do. Okay, so rice has somewhere in the neighborhood of 38,000 genes. A water flea, if you haven't looked at stuff under a microscope, you haven't seen it, but it looks like what it sounds like. Microscopic, flea-like thing floating around in the water. They have 31,000. This guy, if I've ever seen a picture of a beat-down, working for the man, white-collar, depressed, hates his life guy, you know, 21,000 genes. A chicken has like 17,000 genes. So what we find is the number of genes mean nothing. You would think the number of genes would mean you're more complicated, more intelligent, something. But it's not. Not all plants have more than us. Some have less. So the number of genes, turns out, means very little. Now, once you get into things that have like a few hundred genes or whatever, they are simpler. So like we've got 21,000. A water flea has 50% more than we do about. Come on. All right. So next class, we get into a little bit more genetics and cell cycle stuff. Thanks for coming out.